The modern concept of the black hole originated when Carl Schwarzschild extracted a mathematical extreme from Einstein's general relativity, a concept later given its famous name by physicist John Wheeler. Schwarzschild's math mapped out an absolute boundary, a specific distance from a hyper-dense mass where the standard rules of physics simply collapse. We call this boundary the event horizon. The classical explanation for what happens here relies on the idea of escape velocity. According to this model, a black hole creates a gravity well so severe that to climb out of it, an object would need to travel faster than the speed of light. The problem is, concepts like escape velocity belong to Newtonian physics. When you apply them to a photon, a particle of light, the model completely falls apart under Einstein's framework. If we actually want to understand why light gets trapped, we have to discard classical gravity entirely and examine the event horizon through an entirely different mechanism. Before Einstein, physics operated under the assumption that light traveled through an invisible medium called the ether. Under that framework, light could theoretically be slowed down or sped up relative to the observer. The Michelson-Morley experiment dismantled that assumption entirely. This diagram outlines their interferometer setup, which proved that the speed of light is a hard, universal constant. It is completely unaffected by the motion of the source, the observer, or the environment it travels through. Apply this strictly enforced rule to a black hole. A photon entering the event horizon does not decelerate. It does not get dragged backward like a conventional spacecraft struggling against a gravitational tether. It continues to travel exactly at the speed of light. If a photon's speed is absolute and it never slows down, gravity alone cannot explain its capture. To understand the trap, we have to look to the laws of thermodynamics, specifically the concept of entropy. Physicist Ludwig Boltzmann provided a precise statistical definition for entropy. He defined it as a measure of microscopic states. Any physical system has an observable, macroscopic appearance, but beneath that surface are countless invisible, interchangeable microstates that produce the exact same macroscopic result. This formula is Boltzmann's legacy. S is entropy. The letter W represents the total number of interchangeable microstates a system can hold. Consider a box divided perfectly in half. On the left side, we isolate exactly 2,000 gas molecules. The right side is entirely empty. Statistically, there is only one exact configuration where all 2,000 specific molecules sit on the left side. Therefore, W equals exactly 1. Because the natural logarithm of 1 is 0, the initial entropy of this closed system is 0. Now we remove the barrier. The moment a single molecule drifts to the right side, the math changes. For 1,999 particles on the left and 1 on the right, there are 2,000 distinct possible combinations. The microstates immediately expand. The system is driven by probability. It will relentlessly equalize because a Bayesian distribution holds vastly more possible configurations than a lopsided one. When both sides reach 1,000 molecules, the number of possible microstates reaches 2 times 10 to the power of 600. The entropy maximizes simply because this state is overwhelmingly more probable. The arrow of time is exactly the statistical progression. The universe predictably moves from low probability configurations to high probability ones. This strict mathematical flow governs macroscopic reality. It is why you can easily break an egg, but the fragments will never spontaneously reorganize themselves back into a perfect shell. The broken state has higher entropy. This irreversible flow of probability is the only reason you have a memory of the past, while the future remains a prediction. Think about a birthday party you attended last week. You remember it clearly because it is a completed event. Its probability has collapsed into total certainty. Its entropy, relative to the present timeline, is incredibly low. Now, consider a coffee meeting scheduled for tomorrow at 9:23 a.m. That future event possesses massive entropy. Traffic, weather, a late alarm, there are near infinite variables and pathways that could alter the outcome. The past is a locked state of absolute certainty, where W equals 1. The future is an open cloud of high-probability microstates. Now, we bring this thermodynamic reality to the event horizon. Watch as an object breaches the threshold of a black hole. At the exact moment of crossing, a coordinate phase shift occurs. The trajectory toward the center of the black hole stops being a direction in space. It becomes a direction in time. Outside the black hole, an object possesses a normal high-entropy future. It can thrust left, drift right, accelerate, or stop. The probability tree is wide open. Inside the horizon, the extreme concentration of spacetime curvature instantly begins stripping away those future possibilities. The black hole is violently forcing the system's microstates in reverse. It compresses trillions of future possibilities down toward a single inevitability. Trying to maneuver away from the center becomes statistically identical to trying to unbreak a shattered egg. The physical probability required to avoid it simply ceases to exist. The future narrows until only one valid timeline remains. 1 equals 1. Striking the singularity becomes your absolute, only possible future. It is now as locked, certain, and inescapable as a memory of your own past. This forced march down a single, locked timeline carries severe physical consequences due to the steep gravitational gradient. The result is spaghettification. The leading edge of an object experiences a vastly stronger pull than the trailing edge, stretching the material until it breaks. But look at this through the temporal lens we just built. The physical stretching happens because the front of the object is literally closer in time to that absolute future than the back. The mechanical destruction of the object is entirely secondary. The true phenomenon occurring is a fatal, irreversible distortion of time itself, which brings us back to the trapped photon, moving constantly at the speed of light. The photon isn't caught because the black hole is pulling it backward. The singularity is not a physical location at the bottom of a well that the photon lacks the speed to steer around. The singularity is a specific moment in time that is mathematically destined to happen. Photons do not lack the velocity to escape a black hole. They simply lack the ability to escape their own absolute future. Time, ultimately, is the trap.